The next chapter what we see in maths is matrices. Matrices comparatively is a very easy topic, one of the easiest topic of 10th standard. No doubt it is completely new, you are not at all aware about this particular matrices, so you need to be very careful initially, but once you are getting a hack of this, then it's a very easy chapter. Now in matrices, basically you are writing the numbers in a different form, which is called as a matrix. That means it can be written in the form of like this in brackets, you will be writing like this, or you may write it as 1, 2 like this, or you may have something like 1, 2, 3, 4 like this, or it could also be like 1, 2, 3, 4, 5, 6 like this. Sorry. It could be even something like this, or even greater than this, so something like this, anything. So in each and every case you see that you are writing the numbers in the form of rows or in the form of columns over here like this. You can see these are the 3 columns over here, there are 2 rows over here, there are 3 columns over here, and the 3 rows over here. So accordingly, you will find that the matrix will have the number of rows and the number of columns. And this number of rows and the number of columns gives you the order of matrix. As suppose over here in this case there are 2 rows and there are 3 columns, so the order of matrix is 2 by 3. You are not saying 2 multiplied by 3, it is 2 by 3. So it is 2 by 3 matrix. So when I say it's a 2 by 3 matrix, that means that the number of rows are 2 and the number of columns are 3. If I say it's a 1 by 3 matrix, then the number of rows is 1 and the number of columns is 3. So it could be something like this, A, B, C. Right? So the next one, if it is 3 by 1, then it will be like this, A, B and C. So this is a 3 by 1 matrix. So every time when a matrix is given to you, you need to know that what is the order of matrix of that particular given matrix. So that particular thing is important because it is dependent on when we are doing the addition or subtraction of the matrix, we need to know this particular thing because matrix addition and subtraction is possible only and only if the order of both the matrix is same. Did you get this? If the order of matrix of 2 matrix is same, only then the addition or subtraction is possible. If the matrix doesn't have the same, if 2 matrices do not have the same order, then they cannot be added or they cannot be subtracted. So that's a very important part over here. So when we say something like this, another important thing what we can see is that each and every number which is written over here is called, so if I got a matrix like A, B, C, D, E, F over here, then this A, B, C, they are called as the elements of the matrix. So A is an element, B is another element, C is another element. So these are the elements of the matrix, and each and every element can also be coordinated. Okay, we can have a coordinates of that particular thing, like in graph. इसीलिए हम लोग यहाँ पे लिख सकते हैं. We can say that Aij, where I is the row number and J is the column number. So when I say A12, it means A is equals to, what will be the value over here? First row का second column में जो है, that is B. So A12 is B. Now if I say A23 means what? Second row का third column यानी F. So A23 is F. Got it? So each and every element of a particular matrix can be denoted by the formula Aij, where A is represented as the element, I is the row number and J is the column number. So if I am given A11, that means it is the first one over here. So in this particular matrix, it is 1. Got it? So this is how the different objects, or we can say the different elements of this particular kind of a matrix are denoted by. So that's why we have over here that the number of rows and number of columns give the order of matrix, that is 2 by 3 matrix or 3 by 3 matrix, 1 by 3 matrix, 3 by 1 matrix, and each and every element will be denoted by Aij, that is the row number and column number over here. So then if the number of elements are, let's say over here the number of elements are 6, so it could be anything, 1 by 6, 2 by 3, 3 by 2, so depending on whatever are the factors possible, or even 6 by 1, anything is possible. So the number of elements doesn't tell you the type of matrix. The number of elements just tells you how many elements are there. But whether वो इस frame में है या किसी और तरीके से लिखा है, that will depend upon the order of matrix, which is the 2 by 3 or 3 by 2 matrix. Then we see that there are certain kind of standard matrix, or we can just say name given to the matrix. So if the matrix has got only rows but no columns, okay, so if a matrix is such that it has got only one rows, so if R is equals to 1 and number, so if it is like this, like A, B, C, D, then this is a row matrix. A row matrix will have only one row but multiple columns. A row matrix will be one with one row, multiple columns. Similarly, if there is one which has got multiple columns, so C is equals to 1 but multiple rows, so in are many, so it will be this way, like this, A, B, C. The column is 1, there is only one column, but the rows are many. So accordingly, this will be a column matrix. So column matrix. Column matrix will be the one which has got only one column but multiple rows. If the number of rows and the number of columns is same, okay, if I get a particular matrix where R is equals to C, number of rows is equals to column, like 2 by 2 matrix, 3 by 3 matrix, like it is A, B, C, D, or it is 1, 2, 3, 4, 5, 6, 7, 8, 9. So in this way, what happens is, it becomes a square matrix. It's a square matrix. So when the number of rows is equal to number of columns, square matrix. If the number of rows is not equal to number of columns, then rectangular matrix. Obviously. So it may be something like this, 1, 2, 3, 4, 5, 6. Okay, so there the number of rows is not equal to number of columns. Now, if any matrix which has got all its elements as 0, then it is called as null matrix or zero matrix. Very important. All elements 0. So if it is like this, 0, 0, 0, 0, then this is called as null or zero matrix. So null matrix or zero matrix is the one in which all the elements are 0. Now if it is such that the elements are there but these elements are only in a diagonal form from top left to bottom right, यानी it is 2, 5 and 7, बाकी सब कुछ 0, 0, 0 है. All other elements are 0 but only the diagonal elements, like from the top left to the bottom right, are some numbers or some value over here, then this is called as a diagonal matrix. A diagonal matrix will be the one which has got elements only from top left to bottom right and all others are 0. Okay, so that is a diagonal matrix. And lastly, one of the most important one which you will be having in questions also, and that is called as identity matrix. Now, identity matrix is a diagonal matrix wherein the diagonal is 1. So it could be a 3 by 3 matrix with diagonal 1, or it could be something like this also. So a square matrix whose diagonals are 1 each and all others are 0, then it is called as unit matrix or identity matrix. Unit or it is denoted by letter I. So many of the questions में तुम लोग को दिया रहेगा कि sum to matrix is equals to I. That means the resultant is 1 0 0 1 or 1 0 0 1 0 1 0 0 0 1 ऐसे कुछ भी रहेगा. तो accordingly you will know that it will be elements of the diagonal which is unity. Now we have one more kind of a change in matrix, and that is the transpose of the matrix. So I can convert one matrix into a transpose of the matrix. That, for example, so if the matrix A is given as 1 2 3 5 7 9, so you know these are the rows and these are the columns. Now transpose is given as AT or A dash. A dash or AT, both of them represent transpose of that matrix. What is the transpose of the matrix? That rows become columns and column become row. So what happens? AT will be equal to, now let's see, these rows which are like this, now will become columns. So 1 2 3. This is 5 7 9. So you can see over here, the rows are equal to the original column. 1 5 is the row now, which was original in the column. 2 7 is the row which is now original in the column. 3 9 is the row which is original in the column. So you can see the transpose over here means the rows becoming columns and column becoming the row. This can happen to even a 2 by 2 matrix. Like for example, if it is like A is equals to 1 2 5 7, then AT will be equal to now 1 5 2 7. Got it? Though 1 and 5 goes here and 2 and 7 like this. Okay. So this is the transpose of the matrix. Now any two matrices are said to be as equal if all the elements and the position of the elements are the same. So if I have over here two matrix, matrix A and matrix B, if this is 1 2 3 4 and this over here is 1 3 2 4, then they are not equal. They are equal only when this one has 1 over here, this 2 has got a 2 over here, and 3 has got a 3 over here, and 4 has got a 4 over here. So that means A will be equal to B only if B is also 1, 3, 2 and 4. Okay, so equal matrix are the matrix which has got the same elements in the same position and with the same order of matrix 2. Okay, if the same element, same position in the same order of matrix, only then the two matrices are said to be equal. That's an equal matrix. Now one more important thing is that we will be, means in my lectures I will always, whenever I speak a matrix, like for example, if this matrix I have written, I will write over here that now whenever I read this thing out, I will always read it in the form of column wise. That means I'll go like this: A, D, B, E, C, F. All the matrix will always be spoken as column wise. So it will be 1 2 3 5 7 9, 1 5 2 7, 1 2 5 7, 1 5 2 7 3 9. Okay, 1 3 2 4, 1 2 3 4, 1 3 2 4. In this way, whenever I speak or whenever I dictate any kind of a matrix, the matrix will always be dictated in the form that it will be columns wise. I am going to read out the values. Okay, this is what I am going to follow. So that's about the different kinds of the matrix. Now we come to the main part, that is the addition and subtraction of matrix. So when I talk about the addition and subtraction, I said earlier also that the most important thing in the addition and subtraction of matrix is that the order of matrix has to be the same. So if I say over here that 1, 2, 4, 5 plus 1, 3, over here this is of the order of matrix 2 by 2, where here it is the matrix 2 by 1. Because this is not equal over here, addition is not possible. The matrix addition will not be possible if this and this are not of the same order. Order of matrix has to be the same. So even if it is like this, that this is A, B and this is over here A, B. This is 1 by 2, this is 2 by 1, again not possible. Okay, addition or subtraction can be done only and only if both the orders of matrix are same. If the orders are not same, addition is not possible. Now if the order is same, then what to do? So very simple. If the order is same, you are going to just do that operation of addition or subtraction to each and every individual element corresponding to both the matrix. So if it is this way, that says 1, 2, 3, 4 and plus over here is 1, 2, 3, 4, then I just need to do this way, that it is first ye or first ye dono same elements hai, so it is 1 plus 1. Here second one is 2 plus 2. Here it is 3 and 3, so 3 plus 3, and this is 4 and 4, so 4 plus 4. Accordingly, my answer will be 2, 4, 6, 8. Simple. You are just going to add the corresponding elements with each other and frame the answer. That's it. So if it is subtraction, suppose it is like 5, 7, 2, 3 minus 1, 2, 5, 3. Then I just need to do over here, it is 5 minus 1, 7 minus 2, 2 minus 5, 3 minus 3. So answer will be 4, 5 minus 3, 0. This will be the answer of, if I take this as A minus B. Okay, this is matrix A is equals to this much, B is equals to this much, and if I want to find out A minus B, then I just need to do this particular thing. The same way, if it would have been addition, that A plus B, then what happens? This would be 5 plus 1, 2 plus 5, 7 plus 2, 3 plus 3. Accordingly, this will be 6, 9, 7, 6. That is A plus B. Is it clear? So addition and subtraction is very simple, and you will also see that the properties like cumulative property and associative property are applicable to addition here. That means if you have got a thing over here, that first formula is, you can see over here whether I change this in addition, if I change this to with each other, A plus B will be equal to B plus A, and also A plus B plus C is equals to A plus B bracket plus C. So this is the cumulative property and this is associative property. So the cumulative property and associative property both are yes for addition, but of course for subtraction it will be different. So you can see in addition and subtraction the order of resulting matrix is the same, as the order of, so again one important thing is that in addition and subtraction, because it is possible to add and subtract only if the matrix are all of the same order, hence the order of the answer will also be the same. And so addition of matrix is cumulative, and addition of matrix is also associative. This is what is the important part over here. And also we know the additive inverse. So additive inverse will be, of course, a and minus a. So just adding, subtracting each and everything. So if it is a is equals to 1, 2, 3, 4, then the additive inverse, that minus a, will be equal to minus 1, minus 3, minus 2, minus 4. This is additive inverse. Okay, so this was additive inverse, that if a is something, then minus a will be just all the values in the negative form. So if this would have been minus, this would have become plus. So it's just the additive inverse of a and a. And always the sum of sum of this and this will always be a null matrix. It will always be that a plus minus a will be null matrix. You can see here itself that 1 plus minus 1, 3 minus 3, 2 minus 2, 4 minus 4 is nothing but 0, 0, 0, 0. That's a null matrix or zero matrix. So now we are done with this. So we start with the exercise 9a.